are in Introduction to Statistical Learning, Chapter 7, and we're just starting the applied questions, so starting with question 6. Okay, so we're going to analyze the wage data set that's been considered throughout the chapter, and in part, well, let's just skip to part A here in a second. Okay, so we need to install and load the ISLR2 package. Sorry if you can hear my cat in the background. So we need to install the ISLR2 package and then load the data, which is wage, and here I'm just going to call it D and refer to it as D throughout. Okay, and we can get a glimpse of the structure of D here by using the str command. Okay, so now in part A, we're going to perform polynomial regression using age to predict wage. Okay, then we're going to use cross-validation to select the optimal degree polynomial. Okay, and we'll say which degree was chosen, and how does this compare to say to using ANOVA to compare the different models. Each model is going to have a different degree polynomial, right? And I'll also use AIC just for, I guess, fun. Okay, so and then we'll make some plots. Okay, so for the cross-validation stuff, we'll need to use the boot package. So this package right here. So let's first get our polynomial models going. Okay, so I'm going to use polynomials up to degree 10. So I'm just going to set a sequence of polynomials, and then I'm going to create an empty vector that's going to hold the errors of from the cross-validation for all of these. Okay, for each model, right? So for each polynomial degree, I'm going to have a different model. Okay, and then I'm going to wrap into a for loop a model. Okay, so wage and then polynomial age to polynomial degree p, where p is 1 through polyseq here. Okay. Having looked at that, I realized I did this in a funny way here, but that's okay. I could have just set polyseq to 10 and then went 1 through length of polyseq, but that's okay. So again, we'll have a model with just 1 degree polynomial, and then 1 and a 2, and a 1 and a 2 and a 3, and so on and so forth. And then we will use cross-validation with, here I'm using k equals 10, and then grabbing the error, cross-validation error, and then that will go into the vector that we previously created, and then we'll plot those and then identify the minimum. And in this particular run, we get that the minimum is 8, but really at about 3, there doesn't seem to be a lot of improvement. It kind of goes up and down here. So there's that. Okay. So now we're going to also use ANOVA. So now I've just replicated each of those possible models here. Okay. And then I am running ANOVA over them. And I'm also adding an AIC measurement for each model. Okay, and so we'll look at the, we'll see which model we may prefer, given the ANOVA and given the AIC. Okay, so for ANOVA, it gets a little bit confusing here because so these are ordered just in terms of polynomial number, and kind of the traditional way you might do this is you might you might do this stepwise, right? So if model 2 has a p-value that is significant, then we would adopt model 2 over model 1. And if model 3 has a p-value that's significant, we might adopt we might adopt model 3 over model 2, and so on and so forth. Okay? And so here, if we're calling 0.05 significant, then model 4 just misses being significant. Okay? And then in which case we would take model 3. Now we may say, well, God, that's so close, and so maybe 4 is really as good as it gets. But then we have to know what to do with this guy down here all the way at 9, And I think by just kind of standard model selection procedures with ANOVA, we would never have gotten to 9 because we would have already failed at either 4 or 5. Okay, so if we go back up to this cross-validation plot here, we see something that kind of supports some of those tentative conclusions that we get from ANOVA, right? The model really kind of seems to stop improving by 3. Maybe 4 is a little better. It's hard to say. But certainly around 3 or 4 kind of seems to be the sweet spot. And the fact that we got 8 here really just seems to be, you know, a function of the noise that's inherent with the cross-validation possibly. It's hard to say. So, okay, so there's that. Now we may also want to choose a model based on the AIC value. Okay, in which case, now AIC, we might select a model differently. What we might do is to select the lowest AIC score. Okay, so I already have AIC here, but let's just order these in terms of AIC. And here we see that the lowest AIC value comes with the 4th model. Okay, and you know, 3rd is way down the list. But if you look at these AIC values, they're all pretty close. So you know, the fact that there's any order at all really, again, could almost be a function of noise there. But anyway, so with AIC, then we might select 4, the 4th model, right? Which would be here. Again, there doesn't really seem to be much difference between a lot of these. So, okay. All right, so I think we've hacked part A to death there. All right, on to B. So now we're going to fit a step function to predict wage from age, and then perform cross-validation again to choose the optimal number of cuts. Okay, so let me just come down here to the step function. So a step function is not, well, I guess I didn't plot it, but you know, but a polynomial would be kind of a smooth curve along here. But a step function says, well, you're proposing different places in the data where you are going to cut, the x-axis along, and then just take, you know, like the average or some function of the data, you know, in between the cuts, in the intervals between. Okay. So the code is very similar. So I'll let you step through it. You know, the big difference here is that we need to, at each step of our for loop, we need to tell the model how we're going to cut the data, and we're doing that with the cut, and then we regress on the cut, on the age cut. Okay. But then everything's basically the same, and here we get, you know, with cross-validation error, the best model is 8. Okay, and then we're asked to plot what is the best one, and so here's the best model right here, so I need to make predictions based on the model. So from the best model, I'm going to insert new data. What is that new data? Well, it's just all of the ages, you know, from the minimum age to the maximum age in our data. And then I just plot it. So here I'm plotting the raw data, and then I'm going to plot the line here of the best predictions. Now we get that. Okay, so we'll call that good.